We can also talk about the physical properties of a solution compared to the physical properties of the pure solvent. For example, in the wintertime, we put salt on the roads in order to make the ice melt. This is an example of a colligative property. The presence of the solute salt changes both the freezing point and the boiling point of the solvent water. We know that pure water is going to boil at 100 degrees Celsius. If we have a solution where we dissolve, let's say, salt in that water, then the boiling point is going to be some temperature greater than 100 degrees. And for freezing, it goes the opposite way. Pure water freezes at 0 degrees, and if we make a solution out of the water, it's going to freeze at a temperature less than 0 degrees. So this is called the boiling point elevation and the freezing point depression. The freezing point always goes down when you make a solution, and the boiling point always goes up when you make a solution. And the amount that it goes up or down we can calculate if we know little m, the molality of the solution. So the equations that we're going to use, we have a change in freezing point, delta Tf, is equal to the molality times a constant, and that constant is the constant for the solvent. So it's not based on the solute we put in, it's always based on what solvent we're making the solution from. Same kind of equation for change in boiling point. It's equal to the molality of the solute that we dissolve times a constant, and that constant of boiling is for the solvent. So you can look up the constants. For example, water has a constant of freezing that's equal to 1.86 degrees Celsius per molal, and the constant for boiling is smaller, 0.512 degrees Celsius per molal. So if we want to calculate the freezing point and boiling point of a 2.3 molal solution of ethylene glycol, which is the active ingredient in antifreeze, so if we dissolve some ethylene glycol in water, what's the new freezing point? What's the new boiling point? So we can calculate delta Tf is equal to the molality, 2.3, times the constant of freezing. And notice the units molality will cancel, and we're left with degrees Celsius. This is 4.28 degrees Celsius. But notice that's the change in the freezing point. That's not the actual freezing point. So to find the temperature of freezing, you have to remember pure water freezes at 0 degrees, and we just found the change was 4.28. That change, remember, always goes down from 0. So we have to subtract from 0 degrees. And so we get a final temperature of freezing of negative 4.28 degrees Celsius. We do the same sort of thing with the different constant for change in boiling point. The ethylene glycol molality is still 2.3. The constant for boiling, 0.512. which gives us 1.18 degrees Celsius, And again, we have to know that pure water boils at 100 degrees, and we have to remember that the boiling point always goes up by this change. So we're going to add that 1.18, and we get a temperature of boiling of 101.18 degrees Celsius. Freezing point always goes down compared to the pure solvent. Boiling point always goes up.